JET is the European fusion experiment hosted by CCFE. It is the largest magnetically confined fusion device in the world and a key machine on the roadmap to fusion energy. Maintenance to JET, as well as improvements and installation of new equipment, is carried out by the remote handling group at JET. There are limitations on working inside fusion devices, which become radioactive during experiments. The ability to use remote handling techniques is therefore an essential part of running a fusion plant. JET goes into a shutdown period after each experimental campaign to maintain and upgrade systems. During the shutdown, 2 articulated booms pass through narrow ports with only 30 millimeters of clearance on either side to enter the donut-shaped torus. Different tools are mounted on the end of the booms, including a highly dexterous manipulator with 2 arms based on human arms and 2 grippers. This is called the MASCOT. The MASCOT is controlled by an operator in the control room. Every movement he makes is repeated exactly inside the vessel. The operator can also feel what is being done because the MASCOT has a force feedback system. It feels remarkably like the real thing. The engineers work with an array of video camera views and a virtual reality simulator, which displays what is happening in real time. As scientists make advances in fusion technology, remote handling enables them to change JET to try out new concepts. A good example was the replacement of JET's inner wall to prototype materials for the next large international fusion device, ITER. Over a period of 18 months, engineers removed 4,500 carbon fibre composite tiles and installed a mixture of beryllium and tungsten components. More than 90% of the work was performed with remote handling techniques. This transformation means that JET can carry out crucial tests to help prepare for ITER. Remote handling at JET combines advanced mechanical technology, sophisticated virtual reality, and the problem-solving skills and experience of human operators. This allows JET to be efficiently and safely adapted for each new experimental campaign, maximizing the research work which can be achieved. As fusion devices get larger and more powerful, the need for remote handling technology will increase. The systems being developed at JET today are vital to move towards the commercial power plants of the future.